Hi, so to give you a quick recap of where we're up to, I started off by looking at the overall structure of how I might create an escape room in a box. And the idea was that I would have lots of separate puzzle modules, and they were going to be controlled by their own Arduino Nano controllers. They were going to be networked to a kind of a master controller, which is another Arduino, which would control the overall flow of the game and things like the timer unit as well. So I started off looking at some software called PJON. That was the kind of the network interface that would enable all these devices to talk to each other. And I ran a very basic test which seemed to suggest that that was going to work okay. So I created 3 slave nano units and an Arduino Uno, and I could get them to send messages to each other. So that was great. And then I kind of put that to one side for a bit, and then I started looking in more detail at that master control unit. So I wanted that to control the game time and the overall game state as well. And I also wanted to have a display of the countdown of the time remaining for players and things like that. So I found some hardware and I tested that out as well. You can see I also started to do a little bit of the design, the physical design of how this might look in the box. But the problem I had was that the libraries I needed to use in the code to make this hardware work kind of really stretched the limits of the Arduino Uno I was using. So I upgraded to an ESP32 instead, which is a faster, more recent chip. It's got more memory and things like that as well. But the problem I've got now is that the chip, the hardware which I'm running on the control unit, no longer matches that which I tested and got to work in my original network test. So what it feels like is now that I've kind of done one complete iteration of a bit of hardware, a bit of software, a bit of physical design, what I'm now going to do is kind of revisit that all and start again, knowing what I've learned so far, and kind of continue to tweak. And I guess that's going to be a cycle that just continues throughout this whole process, is little bits of iteration on each of the different aspects and then kind of going around in a circle until I'm happy with what I end up with. But before I do that, what I want to do is to document what I've got so far. Although it might not seem like much and we're still a long way away from where I want to be at the end, I have managed to get some parts working already, and I kind of want to make sure that I can refer back to this. If I end up breaking this, in the future, I'd like to be able to get back to a previous state. Obviously with software you can save lots of different versions of your code, and that's easy. But I want to kind of save a state of the hardware that I'm up to as well. So to do that, I'm going to create some wiring diagrams in fritzing. Now, some electronic engineers are a bit snobbish about fritzing, and they sort of say, oh, it's not a real electronic design program and it can't create schematics or PCBs properly. And I think that's a bit harsh. It can do those things, but actually what it's best at is creating this kind of graphic, visual representation of where your wires are plugged into. And that's actually exactly what I want at this stage here. I don't need a professional schematic like this with all of the correct symbols for resistors and capacitors and things like that. I'm not making a PCB. What I want to know is that if I accidentally pull out some of these cables, or if I drop this on the floor and I have to sort of reconnect them, I want to know what pin did the yellow coloured wire go into and things like that. And for that, fritzing's great. So you can see I've already done sort of half of this already. So this is my ESP32, and these are all those displays which I plugged into it, and you can see that big bundle of cables that was powering the displays. This is the representation of the wiring I had there. So I literally, very carefully just traced the wires which I had in front of me and then drew them out in the program here. So you can see I've got my LCD display at the top, and I've got my 8x8 matrix display. I've actually got 4 of these in a row, so I didn't bother putting those in, but just to clarify, I can copy and paste that and sort of line them up. So that is that display there, and those are both using the SPI connection. So you'll see that they share this blue line here, that's the data line that's going to them. They also share this yellow line here, that's the clock line that's going to the SPI pins on the ESP. Then I've got the 7-segment display at the bottom. This was using the I2C interface. So you can see this blue and this kind of whatever colour that brown is there. They're going to the I2C pins here. And I've got 5 volt in red. The orange coloured one is 3.3 volt. So that's telling the display here to use the logic. I've also got my button wired in here between ground and one of the 2 power pins. I've also added a linear potentiometer. So you might have noticed in the earlier videos the LCD display was a bit kind of faded, a bit hard to read on the camera. So I've added this to the contrast pin here, and I'm hoping that that's going to make the display a little bit easier to read, especially kind of in sunlight. If I'm planning this as a game to use outdoors, maybe I need the contrast to be a bit higher, so I've added that in there. So that is the wiring of the kind of the ESP side of things, the more recent display. But what I started off doing, of course, was to look at this idea of a network of these different prop controllers, and I said they were going to be Arduino Nanos, and at the time at least they were running off a PJON network connected to an Arduino Uno. So what I'm going to do is I'm now just going to basically recreate the wiring which I was using for that, because I know that that was working, or at least it was working at one point of time. So if I now kind of fiddle with it in an attempt to improve it, it'd be really useful if I rotated those all in the same direction, wouldn't it? Then I've kind of got a record of a setup which I had at some point in the past that was working again. So you save backups obviously of your software in case you need to roll back to a previous version. I'm sort of thinking this as a little bit like saving a backup of my physical wiring at a point in time that I knew worked, so that if I ever want to kind of refer back to it, I can literally kind of recreate this hardware setup along with the version of the code that was running on it at this point, and I can kind of roll back to an earlier version if I break stuff, which I inevitably will do. So so what I'm doing is I'm connecting all the 5 volt pins together, because this is exactly what I did. 5 volt to 5 volt, 5 volt to 5 volt. Oopsie, move the entire thing. And you can see it's literally like a drag and drop kind of program just to connect these wires together. It's very easy. And then we ended up using pin A0 as the single line data pin, which we're using in the PJON network. So they were all connected together as well. Let's do that one to that one, and then the last wire is from A0 to A0. So I'm going to literally double check by looking at the devices in front of me, and then by looking at the pins that I've drawn them here too. So I've got 5 volt ground A0, yes, 5 volt ground A0, 5 volt ground A0, 5 volt ground. Okay, so that is a faithful reproduction of the hardware which I got to work using the most basic example of the PJON network. So this was pressing a button here caused it to be received by all 3 slave devices, and pressing any button on the slave sent a message that was received to the master. So what I now want to do is I've got these kind of 2 separate bits of functionality at the moment. I've got this one that's running the game timer and the display hardware and things like that, and I've got this one which at least was an embryonic form of a network, and I kind of want to smosh them together now so that I've got this master control device that is on the network and is able to speak to the individual puzzle controllers to send the messages and to receive messages back, and then it can also have a timer and control some LCD displays as well. Okay, so the first thing I did was simply took the code that was working on an Arduino Uno and uploaded it to an ESP32 instead. And actually that worked absolutely fine in that it compiled and it uploaded correctly. Now most Arduino code is compatible with ESP, so it didn't entirely surprise me, but that wasn't the final stage, because I then had another problem. The ESP32 runs at 3.3 volt logic. So whenever you send a high signal to one of the GPIO pins, they go to 3.3 volts. And if you want to read an input signal on those pins as well, that input signal can't exceed 3.3 volts. But the Arduino Nanos, which is what I was using for all of the individual puzzle controllers, they run at 5 volts. Now, when the ESP32 sends a high signal at 3.3, it will still be read as a high signal by the Nano. But when the Nanos send back a high signal at 5 volts, if I was to connect that directly to the ESP32, that would blow the GPIO pin that was plugged into. That would exceed the limits of the pin and would probably damage the board. So I had a number of different ways I could solve this problem. The first solution is simply to go back to using an Arduino Uno again. The reason I stepped off it was because the Arduino wasn't powerful enough to power all these displays I was planning useful. But I don't really need to use all of them, so I could go back to Uno or I could go to a Mega, but that kind of felt like I was kind of avoiding the problem rather than solving it, because you know, Unos are quite dated hardware now. I wanted to use the better features of the ESP, and I sort of didn't want to get set back by the fact that the Nano's running at 5 volts. So what I could do instead is upgrade all the Nanos in the puzzle controllers to use a 3.3 volt controller like a Wemos D1 Mini. So then I'd have a whole network running at 3.3 volts, and that would work as well. The problem with that is that, you know, I've got a load of Arduino Nanos, and actually they're very reliable controllers for each of the individual puzzles. A Wemos D1 Mini's got a load of functions that I wouldn't make use of. It's got predominantly a Wi-Fi, and it has got other limitations as well. So it's only got one analog input pin, for example. So I haven't quite decided what puzzles I'm going to include yet. But most of my previous projects I've used Nanos in, and I know they work with Nanos. So I don't really want to upgrade them to Wemos D1 Minis and then find out that I've got some other problems with things I can't do on those boards. So then I thought, well, okay, maybe there's some way of working with 5 volts and 3.3 volt devices on the same network. Because you can do that with SPI buses or with I2C buses using a logic level converter, which is what this is. See, the idea here is that the bus is running at a certain voltage, so let's say it's a 5 volt bus, but every time you have a 3.3 volt device you want to connect to that bus, you put one of these logic level converters in between the signals, and it will feed a high signal on one side into a low signal on the other side, and likewise it's bidirectional, so you can have a low signal on this side will translate to a high signal on this side. And I thought, well, that's great, I've got a load of these logic level converters, so let's slap those in. But unfortunately, that didn't work either. And I don't really know why. I contacted the developer who writes PJON and said, look, I'm trying to use this, I think it should work, but it doesn't. Any ideas? And I guess it's something to do with the very specific timing of the way that the data gets transmitted on the network. So you've got a sequence of clock signals of highs and lows, and it's to do with that rhythm of changing between high and low values is what sends the data over the network. And when you've gone through a logic level converter, my guess is that it's introducing a delay or distorting that timing pattern slightly between the low signal and the high signal, and as a result the data is getting corrupted and it doesn't work. So that doesn't work either. Then I thought, okay, well, I could use a 2-wire data signal instead. So rather than, at the moment I'm using a single wire connection, and that is both transmitting and receiving between all the devices. If I had a 2-wire connection instead, so a transmit and a receive, what I could do is on the receive line of a 3.3 volt device, step down the 5 volt signal just using a pair of resistors. So let's say I've got a 5 volt signal coming in. If I create a resistor divider with a 2 kilo ohm resistor and a 1 kilo ohm resistor, that's going to split that signal into 2/3 and 1/3 of the voltage. And if I read off at the midpoint of those, that will give me 3.3 volts, which would be fine. And on the transmit line, I can send out 3.3 volts and it'll be read by a 5 volt signal as high, so that's just fine. But the problem with that is I'd kind of I like the elegance of having a single wire solution and the convenience of it. And I kind of convinced myself that I was going to do this project with only a single data line. So to now cop out and say actually every device needs to have a power, a ground and 2 data lines going into it seemed not great either. So then I had one more idea, which is the one I've gone with, although I'm not 100% happy with it, which is, okay, I know that the ESP32 works to control the displays. I know that works. And I also know that the Arduino works on the PJON network. So let's not try to actually change those 2 facts. Let's try to keep those the same. And instead, what I'm going to do is add a serial connection between an Arduino and an ESP32 on the master controller. So the master controller is going to have 2 processors on it. It's going to have the ESP, which is going to do all the game functionality. It's going to do the display and the timer and all those things which I've already coded on it. And then I'm going to have the Arduino, which is going to do all the sending and receiving commands over the network to the devices, which is the thing which is already running on it. And then I'm just going to pass messages between the 2 using a serial connection. So connect the transmit and the receive lines of one of the serial ports on the ESP to the Arduino serial transmit and receive lines. The ESP itself has actually got 3 UART ports, but it's got 2 that are easily available anyway. So I can still do that without disturbing the serial receive functions, things like that. It's a bit of a clunky solution. I don't 100% like it because it does mean that I've made the controller more complex than it needs to be. But I kind of figured if I can get it to work for now, it'll do, and then I can possibly revisit it later and see if there's a more elegant way of writing it. But for now, I thought, okay, what I'll do is I'll have those 2 separate code blocks, connect the hardware together with serial, and so I was going to write some more code that's kind of tested that out. Now, I'm imagining everyone watching this video is familiar with using the Arduino IDE to upload code, and then also having a serial monitor window open, which you can use to send little messages, to check the value of variables as you debug things, and you do that using this serial.print command in your code. What you may not be aware of, or what you may not have used in the past, is if you're writing a sort of a network application like this one, where you have multiple devices and you're kind of developing the code and you want to test the code on several of those devices at the same time, you can load multiple instances of the Arduino IDE, with each one having a serial monitor that is monitoring a different COM port. So to do that, rather than just going file open and opening 3 different sections of code, what you actually need to do is open 3 instances of the IDE. So load it from your start menu or wherever your shortcut link is. And then each one of these windows now is kind of operating separately. So you can see this one here, this is targeting my node 32. So that's my kind of main controller. And it says on the bottom here, node 32S on COM3. The one in the middle, this is the new Arduino Nano, which I've just wired via a serial connection to the ESP32. That's on COM5. And then on the right hand side here, I've got one of my slave devices. So this is also an Arduino Nano, and this one's on COM6. If I had more COM ports on my laptop, or if I had like a USB splitter or something like that, I could have more of these windows open and actually monitor the output on each of my slave devices as well. So that might become useful really later on. If I get sort of one slave is behaving differently from the others, I can actually check the messages received on each individual one. But for now, I've got these 3. So what I've done is I've kind of I ripped out the code from the master module. So the master module is pretty similar to what it was doing before anyway. It's mainly just controlling the displays and the game timer. And then it's got a little bit of new code though, relating to in the loop here. So I'm checking whether any information has been received on the serial 2 interface. So the ESP32 has got more than one UART connection. I'm using serial, this one here, to write to the window at the top. So that's my kind of normal serial.print. I'm using serial 2 to write to the Nano, which is the board in the middle here, and then that is going to pass stuff backwards and forwards to the network. So if anything's available on serial 2, that means that there's data that's coming from the network via the Nano in the middle, and I'm going to read it. I'm also going to write it to this window here just so I can see what that message is. And then I've just started to define a couple of different messages or message types that might be received across the network. I've only put in 2 for now, which I've called strike and pass. In one of my earlier videos, someone made a comment about Keep Talking and Know What Explodes, which is a computer game that has a modular bomb that you have to defuse, which is got sort of some very similarities, I guess, to what I'm creating here. And the language that they use in that game is the concept that each module is capable of sending a strike or a pass message. So strike means that the user input an incorrect, made a mistake or a failure or lost a life or whatever you want to call it. A pass in this case means that they passed the module successfully. So in my code in the past, I've normally called this solve rather than pass, because pass kind of makes me think of when you pass on a question, that's like a question you can't answer. I don't think of pass meaning solve necessarily, but I've kept their language for now, just sort of while I work out exactly what messages I do want to send. And you'll see what I've done is, so when a strike is received, so this is a bad event, this is the user's done something wrong, what I'm doing is I'm adding to the amount deducted from the time, so I'm giving them a time penalty basically. And when a pass is received, so this is a successful solving of one of the puzzle modules, then I am subtracting from the deducted time. So in other words, I'm giving them time back. Again, that's not necessarily the actions I want to stick with at the end, but I wanted something that I could easily see on the countdown display whether I was having an effect or not. But this doesn't actually have all the networking stuff itself. What this does is this just reads what was on the serial connection and then does some actions based on that. The serial connection itself is populated by this thing in the middle. So this is running on the sort of the Arduino Nano daughter board, which is connected to the SP32. So again, you can see this is where all my PJON code is. This is now device 100 because this device over here isn't really on the network at all. It's just connected to this one, which is. And this is basically the same code as I was running before. And the difference is here. So if anything is available on the serial connection here, well, that means that the master module has written something to it, and if that's the case, it's going to send it to all devices on the network, and it's just going to forward whatever the message content was. So that's what character C is. And up the top here in the receiver function, if something was received on the PJON network, what we'll do is we'll print it to the serial connection, which comes back to the host, which is what gets read here. So these two are just passing. This is like what we call a pass-through sometimes. This doesn't actually add any functional logic in this middle code at all. All it is doing is translating a serial interface between the ESP on the left and here, and a PJON interface between the middle code and the one on the right. And my code on the right, well, this is an example of one of the slave modules. And again, what I've done is kind of the minimum amount necessary, I think, to test whether it's actually doing something useful. So I've added some LEDs to it. I've got a green LED and a red LED, and they correspond to, again, using the language that I'm using over here. So this is when you pass the module. I am going to change that because I'm not happy with this idea of passing. It confuses me. So normally I'd say when you solve the module, it turns green, and if you fail the module, it turns red. I guess the reason why I'm using strike rather than fail is because fail suggests kind of a permanence, like this module cannot be solved until something is reset, whereas a strike simply means it was a wrong guess and you might get 3 strikes and you're out kind of thing. At the moment, I haven't decided whether the module itself is going to keep track of how many incorrect attempts and things have been made, or whether that's something that the master device is going to keep track of. So whether you kind of have an overall number of incorrect guesses you can make that are shared between all the modules, or whether each module has its own count. Those are the kind of decisions I'm going to
come on to in the next kind of stage, I guess, but I haven't made that decision yet. And then what we're doing here, so we'll respond to a ping. This is just, again, this will be the next bit where I want to detect what devices are actually available on the network, which modules have been plugged into the box. We're going to get the master device to send a ping message to all of them, and if they respond with a pong message, that means we know that device is online. So I've kind of started to write the code for that, but that's not kind of totally functional yet. And then I've got these two buttons, so I've got a strike pin and a pass pin. And what happens, well, if the device is not currently active, then I don't do anything with the buttons at all. I turn both LEDs off. If the device is currently active, well, then the green LED is off, but the red LED is on. So that shows that this is a puzzle that is currently waiting to be solved, basically, when it's got one red light on. And then while it's in that state, for now, you basically just have to press the right button. That is the puzzle. Not much of a button, I know, but we'll keep on building on this. So if you press the strike button, that was the incorrect button to press, and then we send the strike message onto the bus. Remember that gets picked up in the receiver function in the middle here, which writes it to the serial connection, which gets picked up with the serial read function here. So this strike that was sent over here gets passed all the way across, and that is what's going to add our time penalty on. Otherwise, if the correct button was pressed on the slave module, so if the pass switch was pressed, we're going to send the pass message, that will be passed on, that will be picked up here, and that will give us some extra time. Okay, so that's basically the functionality I've added in. If I now kind of show you, so I started talking off with these serial monitor links at the top, so I've got these devices plugged at the moment, so I've got them turned on. If I start the game off by pressing the activate switch on the ESP32, you'll see I've got activating network online, pass received here, and a sent message from the host. That gets sent to the middle device, sent message from the host, and that gets received over here, message received. I've obviously got a bit of a problem with the way I'm printing out the character encoding there at the end. But I've had a message that was sent from left to right. If I now press one of the buttons on the slave module, so that was the pass module, which gets sent back from there. I've got received message from slave here, and then I've got received message from slave, pass received on this side. So I need to do a little bit of fiddling around with the printing out of the messages. But hopefully you can see I've got messages being sent from one side to the other. If I now do that on one of the other devices as well. So that one was a device I'm not currently monitoring, but it's still on the network. So in this case, it just got received by the daughter board, the PJON conversion into a serial then, and it got converted here as well. And my final device here as well, I can send that as well.
So here's the hardware, and here's my master controller. So the difference is now I've still got the same displays, I've still got the same button, and those are still connected to the ESP32, except I now also have a Nano on this board here. So these two are connected via a serial line, so the transmit and the receive lines of these two devices are connected. And then the Nano here is what is wired through this black and red and blue lines to the three slave controllers, which I've got in these Nanos at the top here. So I'm actually sending ground and power and the signal lines. So these three are being powered from the master controller, as well as actually having a data network to them as well. And then on the slave devices, you'll see I've added a green and a red LED just to indicate the status of those individual puzzle controllers, as well as just two little micro buttons which I'm going to use to simulate messages sent across the network. So if I now actually connect the master controller to power, so I'll just plug the controller in there. Now when this first powers up, what we should find is that we've got power lights on all the board, but at the moment the starting state of the game is inactive, so nothing's actually happening at the moment. If I press this button here, what should happen is that the countdown will start and each of the individual puzzle controllers will become active as well. So you'll see the red LEDs are on each one, and I've got the timer countdown started here. I'm still using all 3 displays at the moment. Like I say, I'll probably change that in the future, but that's where we are at the moment. And what I can do now is that if I press one of the buttons on these individual controllers, I can send a message which will send that pass or that strike command, and that will hopefully change the message on the clock accordingly. So let's try this button here. So that was a solve command on this puzzle. I've got a double tap, unfortunately, which has changed the LED to green. You can just about see that's a bit faint. Probably need to reduce that resistor value rather than red, and it's increased the time on the clock. And if I do that on one of the other ones again, oh, that was a strike, so I got that wrong. In fact, you can see something's a bit weird. I'm getting double button presses on the buttons here, so I just need to check that I'm actually sending the right signals. But I am at least getting communication from the devices to the controller. And this button, now that the game is active, what this button will do is this will reset the controllers. So what that should do is put these back into an unsolved state, which will turn the red lights on again, like that. And it will pause the clock, of course, as well. So I need to debug exactly what's going on the messages, and also I really need to think about what messages I want to be sent between all these devices and what functions I want them to have.